let's dive in. You've given us, wow, a lot to work with here. Research articles, a webinar transcript, all on developmental and epileptic encephalopathies. DEEs? It's heavy stuff.
It is, yeah.
But that's what we do here.
That's why we're here. And, the name might sound a little intimidating,
It does.
but it's a really important area, especially for children who are facing, both developmental challenges and epilepsy.
And it's not like just because they have epilepsy that it's harder for them to develop. This is its own thing, right?
It is. It's not just, epilepsy makes development harder. It's that the epileptic activity itself is part of the problem. The seizures and even those brainwave patterns, those abnormalities we see on the EEGs, they actually contribute to the developmental problems. It's all very intertwined.
So the brain is dealing with these, like, electrical storms, and at the same time it's trying to develop typically.
Exactly.
Wow. Okay, so to unpack all this, one of the first things that jumped out at us from the research was this DEE triad. Sounds kind of mysterious, right? Like a medical mystery novel or something.
Yeah. Yeah. It's a good term, I think, because it really highlights the three key things that doctors look for when they're trying to figure out, what's going on. So first you have the seizures. Of course, those can be all different types, different severities.
Right.
Then there's the EEG, the brainwave test. That's where we see those unusual brainwave patterns, and that tells us something's not right. But it's that third element, the developmental piece, the slowing down or even regression, that's what really makes DEEs different.
Okay, so that third part, that's where it becomes about more than just managing the seizures, right?
Yeah.
It's about how it's affecting the child's whole development, their ability to learn and grow.
Exactly. And that's really what makes DEEs so challenging. We're not just trying to stop the seizures, we're trying to protect a child's future.
In the webinar transcript, they had this really powerful example, Randall-Kleffner syndrome. Kids start off developing totally normally, and then suddenly they regress, especially their language skills. And this can happen even when their seizures are under control.
Yeah, it's heartbreaking. And it really shows how sneaky these conditions can be, because even if you don't see a seizure happening, that underlying epileptic activity, it's still disrupting brain development. Like if you had a radio and there was all this static, that's kind of what's going on. So finding it early is so, so important to try and minimize that damage.
Which leads us to another huge piece of the puzzle that's just exploded in recent years, the genetics of DEEs. It's mind-blowing how much we've learned. Over 300 genes linked to these conditions.
I know, right? It's really amazing what genetic research has been able to do.
But I'm guessing it's not as easy as saying, okay, this gene causes this DEE.
Yeah, right. It's not that simple.
Okay, so explain that.
So research is showing us that one gene can actually be involved in a few different conditions, and even the severity can be different.
Oh, wow.
So, for example, you've got the SCN1A gene. That one's linked to Dravet syndrome, which is a very severe type of DEE. But it's also linked to GEFS plus E, which stands for genetic epilepsy with febrile seizures plus, and that's a much milder form.
So two kids could have the same gene, but one has a really severe form of DEE and the other has a milder form. How does that even happen?
That's the million-dollar question. It's really fascinating. We think there are other genes involved, kind of like modifiers, that can affect how that main gene works.
Yeah, okay.
And of course, we can't forget about environmental factors. Those probably play a role too. It's a really complex interplay, and we're still learning, but understanding all these nuances is going to be key.
Because in the end, it's not just about putting a name on it, right? It's about what that specific cause means for their treatment, for other problems that could come up.
Exactly. Knowing the underlying cause, the root of the problem, it affects everything. How we choose to treat it, what other conditions they might be at risk for, even family planning, because there might be a chance of having another child with the same condition. It's like a ripple effect.
There was a story in the webinar that really stuck with me about a child who was misdiagnosed, given the wrong medication, and it actually made their seizures worse. It's scary to think what can happen when we get it wrong.
It is, and that story really highlights how crucial it is to get the diagnosis right and to get it early. Even with DEEs like Dravet syndrome, which we've known about for a while, our understanding is constantly evolving. What used to be a pretty clear-cut definition is now getting more complex as research shows us that there is a wider range of how it can show up.
So even the classic cases are getting more complicated. That's where those fuzzy edges you were talking about earlier
Right.
come in, right?
Yeah.
With Dravet. I'm really interested to hear more about that research.
Let's dig into that. It's fascinating stuff. Okay, so those fuzzy edges of Dravet syndrome, it's really interesting. We used to think Dravet always looked the same, you know?
Like textbook case.
Exactly. Textbook. Like an infant about 6 months old has this really long seizure, usually brought on by a fever. We thought that was the classic sign. But turns out it's not always so straightforward.
So we're seeing some variations in how that first seizure looks.
Yeah.
What kinds of differences?
Well, the age when it starts can be different. Sometimes it's later in infancy or even in childhood. And the type of seizure they have at first, that can vary too. Usually it's a hemiclonic seizure where one side of the body is affected.
Right.
But we're seeing kids who have generalized tonic-clonic seizures first, which is different.
So the early signs might be more subtle or more varied than we thought. I imagine that makes diagnosis even harder, right?
It definitely does. Doctors need to be really on the lookout for Dravet, even if it doesn't perfectly match that classic picture we used to have, especially because, like we talked about earlier, if it's misdiagnosed, the treatment could actually do more harm than good.
Right, like that story from the webinar where the wrong medication made the seizures worse.
And speaking of treatment, even when Dravet is diagnosed correctly, those typical anti-seizure meds, they don't always do the trick, do they? Unfortunately, no. DEEs are complicated, and getting the seizures under control is just one piece of the puzzle. But the research you gave us, it highlights some promising new therapies, fenfluramine, for example, and the ketogenic diet. Those are showing some real potential.
Yeah, I've heard a lot about fenfluramine. What's different about it
Yeah.
compared to the older medications, I mean?
For a lot of people with Dravet, it's been pretty remarkable. I mean, it's not a cure, but it's been very successful in bringing down how often they have seizures, sometimes by a lot. And that obviously means a better quality of life for both the child and their family.
That's huge.
It is. And then there's the ketogenic diet, high fat, low carb. We've all heard of it, but I'm curious, how does it actually work to help with seizures?
Yeah, I was wondering that too.
It's pretty fascinating, actually. By shifting the body to burn fat for energy instead of glucose, it seems to have this anti-seizure effect. We're still trying to figure out exactly how it works, but the results have been really encouraging.
It sounds really intense, though. Is it hard for families to stick with it?
Yeah, it can be tough, especially at first. It takes a lot of planning, making sure they're eating the right things, and it's a big change. But a lot of families find that the benefits are worth it. And there's even some evidence that it might be helping with more than just the seizures.
Oh, really? What else is it doing?
Well, the research is still ongoing, but there are some signs that the ketogenic diet could actually improve cognitive function in some people with DEEs. And there's even some studies suggesting it might help with some of the behavioral challenges that often come with these conditions.
So it's like a 2-for-1, maybe even a 3-for-1. Tackling the seizures and maybe even helping with other things too.
Yeah, exactly. And that leads us to what I think is the most exciting area, precision medicine. It's about moving beyond these general treatments and actually tailoring the treatment to the specific genetic cause of the DEE.
You mentioned that earlier. Can you give us an example of what that looks like?
Sure. So imagine, instead of just trying to stop seizures in general, we can actually target the root of the problem, like at the molecular level. We know that some of those SCN1A and SCN2A mutations we were talking about, they mess up the sodium channels in the brain.
Right?
So now we have drugs called sodium channel blockers that can directly address that specific problem.
So we figure out exactly what's broken and then find the tool that fixes it.
Exactly. And it's not just limited to sodium channels. As we learn more about the specific genes and pathways involved in DEEs, we can develop even more targeted therapies. There are even clinical trials happening right now for gene therapies. The idea is to actually replace or fix the faulty genes altogether.
Wow, that's incredible. It sounds like the future of DEE treatment is going to be very personalized.
It is, and it's changing so quickly. It's really an exciting time. Of course, there are still a lot of challenges ahead, but the pace of research and the new discoveries, it's amazing. Every breakthrough brings us a little bit closer to understanding these complex conditions and ultimately to more effective and targeted treatments.
It feels like we're on the edge of a whole new era in how we approach DEEs. But all these advancements, especially the gene therapy stuff, it makes you think about the ethics of it all. Yeah. Yeah, it's like a whole new world, isn't it? And like any powerful technology, gene therapy definitely brings up some serious ethical questions.
Absolutely, it does. I mean, we're talking about changing the very essence of a person, right? The building blocks of who they are. That's not something to take lightly, especially when you're dealing with conditions like DEEs, where cognitive development is such a critical factor.
It really makes you think, where's that line? between treating a medical condition and, like, enhancing someone's abilities. That's a tough one.
It is. It's a very blurry line. And it's not just about the science itself. It's about the impact on society, the ethics of it all. It's really important to have these conversations out in the open to involve scientists, doctors, and most importantly, the families who are actually living with these challenges.
Because at the end of the day, all these amazing advancements, they need to be about helping the people who have DEs, not just about pushing the limits of what we can do.
Exactly. That's the goal. And that's why the research can't stop. We need to keep learning, not just about developing new therapies, but about understanding the full impact of those therapies, making sure they're used responsibly, ethically.
It's a good reminder that science isn't just about, cold, hard facts. It's about people, real people, and their stories,
It is very much so.
and how we use that knowledge to make a real difference in people's lives.
Well said. We've covered a lot of ground in this deep dive, haven't we? From the DE triad to the genetics revolution, and now this incredible potential of precision medicine. It really shows how far we've come in understanding these conditions.
And, when you zoom out and look at the big picture, it becomes clear that DEEs are much more than just a diagnosis. They're pushing us to explore, like, what makes us human, how our brains work, how our genes shape who we are.
They are. And as devastating as these conditions can be for individuals and families, they're also driving some truly incredible innovation. We're developing therapies that, not that long ago, would have seemed like something out of science fiction.
So for those listening, even if DEEs aren't something that directly affects you or your family, why should you care? What's the takeaway here?
I think it's important to remember that these stories, these scientific journeys, they affect all of us in some way. They're about figuring out how the human brain works, they're about pushing the limits of medicine, and they're about wrestling with some really tough ethical questions that are going to shape the future of healthcare for everyone.
It's a powerful reminder that every scientific discovery, no matter how small it might seem, can have a ripple effect that touches us all.
Absolutely. And it's also a testament to the resilience of the human spirit. The families who are facing these challenges, they're the real heroes. They're
Yeah.
advocating for their children, they're supporting research, they're inspiring all of us with their strength and their determination.
So, as we wrap up this deep dive, we want to leave you with this thought. Even when things seem really complex and uncertain, there's always hope.
There is.
Science is always moving forward, always opening up new possibilities.
And with every new discovery, we get a little closer to a future where DEEs are no longer a source of despair, but a catalyst for understanding, for innovation, and for a deeper appreciation of just how amazing the human brain is.
We've only scratched the surface of this topic. It's so complex and it's changing all the time. But hopefully this deep dive has, sparked your curiosity and given you a glimpse into the world of DEs and the incredible potential of science to change lives.
I hope so.
Keep asking those questions, keep exploring, and keep diving deep.
Until next time.